Today we're doing section 2.4, dividing polynomials, day 2, and we're going to discuss synthetic, which is the easier method to doing long division. So notice it looks about the same. One thing that we have to do is whatever you're dividing by, you set equal to 0. So you always have to attain the 0 or the x-intercept to determine what you're doing in synthetic. And we list our coefficients, so I bring the 5. Notice I'm missing a squared term, so I have a 0, 6, and 8. So we're going to drop our 5. And the process here is that I multiply -2 and 5, and I write that number up here, which is 10. One of the main differences from synthetic to long division is that I'm adding, not subtracting. So 0 plus 10 is 10. Now I multiply. -2 times 10 is -20. Again, I add, which is -14. We multiply. And then we add going straight down. And then to interpret this answer, I'm now down a degree. So I started in the third power. That means I'm down to the second power. And these values represent your coefficients. The 14 is our constant, and 36 represents our remainder. So synthetic is implied to be the shortcut to long division. It's supposed to be easier. It is something that we'll probably utilize a little bit more. So it is important that you learn this process. So we're going to kind of take that skill of synthetic division, and I'll show you how we're going to apply it in problems. So if your polynomial is divided by x minus c, so c would be like a number if I'm dividing by x minus 1. If the remainder theorem says if you evaluate the function at that value, whatever you get as your output would also match the remainder that you would get. So for example, if our function is x cubed minus 4x squared plus 5x plus 3. So if I did synthetic at the value of 2, I drop the 1, 2 times 1 is 2, I add, -2, multiply, -4, add 1, 2 times 1 is 2, 3 plus 2 is 5. So if I evaluate the function at 2, let's look sloppy. So if I evaluate the function at 2, I have 2 cubed minus 4 times 2 squared plus 5 times 2 plus 3. 2 cubed is 8. 2 squared is 4 times the -4 is -16 plus 10 plus 3. 8 minus 16 is -8 plus 13. Notice I still get the answer of 5. So notice the remainder when I did synthetic at 2 is the same as the output if I evaluate the function. So that kind of brings us to the factor theorem, and the factor theorem says if I evaluate the function and I get 0, that means whatever binomial that value came from is a factor of the function. So to kind of show you how this applies, it says solve 2x cubed minus 3x squared minus 11x plus 6 equals 0, given that 3 is a 0. So if I were to evaluate this function at 3, I would get 0, which means I'm not going to get a remainder when I divide using synthetic. So notice I didn't change the sign of this either. It's coming out right now. I'm telling you 3 is a 0. I'm not saying the binomial is x minus 3. I'm saying 3 is a 0. So the sign does not change. So 2, -3, -11, and 6. So I drop the 2. 2 times 3 is 6. -3 plus 6 is 3. 3 times 3 is 9. -11 plus 9 is -2. 3 times -2 is -6. So to kind of interpret this, so I know I'm down to the second power. And since the answer is 3, I know that that came from an x minus 3. So that's what I was saying. it becomes a factor. So this binomial is a factor to the problem. So if I want you to solve, I need to go further. So we have to figure out if this equation is factorable or not. So I would multiply A and C, which is -4, and figure out if something multiplies to be -4 and adds to be 3, which it does. It's a 4 and a -1. So I'll have 2x squared plus 4x minus 1x minus 2. And I grouped the first two and the second two. I can take out a 2x. So I'm left with x plus 2. And I can take out a -1, and I'm left with x plus 2. So this factors to be 2x minus 1 and an x plus 2. And I know this x minus 3 was already out front. So to solve, I get the answers of a +3, a -2, and if I solve that middle one, I'd add 1 over and divide by 2. So I get the answer of 1/2. So those are my 3 answers. So notice you needed that first 0 to do synthetic with. So if you tried to just go right into the grouping method, nothing would match up with it. And that's why it's not factorable by grouping. So that's all for today. We're going to do some more practice on this tomorrow.